This is a favorite test question of mine. We have two equal magnitude forces, F, acting upon a particle with a mass of 25 grams. The angle between the two forces is 36 degrees. What must the magnitude of the two forces be if the particle starts from rest and is going 15.5 meters per second in 3.2 seconds? So we're going to again unite Newton's second law in vector form and a kinematic equation and unite the two by way of acceleration. So if we look at the picture first and try to examine the vector issue, the first thing I'm going to do is I'm going to bisect the 36 degree angle so that this is 18 degrees and this angle is also 18 degrees. And then identify the net force in the, I'm going to call this the x direction. I'm going to identify the net force in the x direction. So the net force in the f direction is 2 times f, since there are two identical forces, cosine 18, and equals 0.025 kilograms. So that's our 1 unit issue, and I've highlighted it in yellow here. Alright, so we have to change the mass to kilograms, and then we're operating with meters, kilograms, and seconds. The SI system times acceleration. Alright, so two unknowns. Can't do anything with two unknowns in one equation, but I can get the acceleration from kinematic data. Alright, so we have a v initial, which is 0. We have a v final, which is 15.5 meters per second, and we have a delta t. So we have enough to define based on the definition of acceleration, which is v final minus v initial over delta t. So this is 15.5 minus 0 over 3.2. And since I did make mention of units, I might as well kind of continue with them. And we're going to get 4.84 meter per second squared for our acceleration. So there's the big tie-in right there. So now we have the acceleration from kinematic data, and we can now proceed to find f. So 2f cosine 18 is equal to 0.025 times 4.84. I've left off my units because they're consistent, and I know that the force is going to come out in newtons, which is a derived unit. And for newtons, I'm going to get 0.064 newtons for my final answer. So each of the individual, the two forces acting on the particle, have to each be 0.064 newtons for it to behave in this manner.